This is evolution. I'm going to talk about some of the circuits, different defrost timers, and what's different about them. And then a bunch of different manufacturers do a lot of things that, over the years I've seen, even back in the 80s and 90s. I went to a freezer one day and the customer said it wasn't cooling. I'm opening and closing the door, the evaporator fan's not working. I hit the light switch is going on and off. I go to the back, the compressor and everything's running, and the fan wasn't working in the freezer. So I told the customer, I'll be right back. I'm gonna go get a fan out of my truck. And when I came back to the customer's refrigerator, the fan was running, and I'm saying, why is this fan running? It wasn't running before. And then I had to look at the schematic, and I realized, oh, they wired this differently. And that's some of the different things that we're going to talk about. Today I won't get into the actual electronic board and this other fuse board that you see in the bottom. That'll be part 2. And I'll actually include like refrigerators that the defrost is built into the main control board, and how that works within that. So anyways, good afternoon everybody, and let's get started. Next slide here. So everybody who's worked on refrigerators knows that there is one second, I'm sorry. That there's these 3 parts make up a defrost system. There's a timer. The timer every so often goes into defrost. It does it for a certain amount of time. We have a heater that melts the ice off the evaporator, and we have a thermostat in series with it for safety. One second, I'm sorry. So what could you do different to these 3 components? And I could show you 4 or 5 different wiring diagrams that are going to show you how we do these differently. So I'm going to break down the different timers, the different thermostats, a little bit different heaters. The heaters, there's not a lot of coverage on that. They're just heaters. But first of all, what does anybody know what defrost really is, or what it's doing?
Is it defrosting the ice that builds up on the evaporator?
Okay, so the evaporator runs at about 15 degrees below zero. All the humidity, and I live down here in South Florida, so the humidity is higher than someone lives in Arizona or something, but all the humidity in the air, every time you open and close the door, goes in your freezer, and it runs over that evaporator, starts to build ice, which is 32 degrees. And if you get enough ice build up on the evaporator, you're going to affect the ability to cool. And so we need to get rid of that ice so that the air flows over the actual evaporator and not over the ice. So that is a defrost system. That's the purpose of it, that we'll lose efficiency or cooling if we're not defrosting. If you go to a customer's house and any one of these defrost components have failed and you do not have a replacement, if you manually defrost a refrigerator, a customer can get 5 to 7 days of cooling before you come back and install the part. So that's what a simple defrost system is. But let's break down the components now. So I got 2 diagrams in here, and I got a couple of questions to ask. I want you guys to take a look at it closely. The circuit diagram on the left, what cycle are we in? Anybody have any ideas?
I would say we're in I'm looking at, I see the switch on the thermostat is closed on this one.
Okay, so when it's closed, it's usually calling for what?
It's in a cooling cycle, because if it's closed and there's power going to the relay and the compressor.
That's correct. So, and let me just get my little marker here and try to do this circuit. So that's too big, sorry. So power goes in, goes through the thermostat, and basically when the compressor is running, that's the circuit for the compressor. But notice we have an evaporator heater and a drain heater. So this evaporator heater is our defrost heater. Okay, this is the very first defrost system that was ever created before they had mechanical timers. But let's take a look at this other thing, because I'm in a minute I'm going to talk about that too. Is that we have these two other heaters, and they're energized right now, which are the Style and Mullion heater. Does anybody know what those two heaters are?
Well, another Mullion heater is the heater that's usually between the double doors up top that keeps the gaskets warm.
That is correct, but Mullion heaters go back to refrigerators that are top mount. Back in the 80s, your top mount refrigerator, you have that strip that runs across between the two doors, and inside that wall there's an electric heater. And the idea is that the freezer gets so cold. I know you have a gasket there, but the metal, part of the metal's in the freezer and part of the metal's out the freezer, but the metal itself will get so cold it will sweat. And it'll cause rust, it'll cause mold on your gaskets and everything else. So they put this little wire, and it's a heater, a very, very low wattage heater, just enough to raise the temperature above what they call like the dew point, to prevent moisture from forming. And then the Style heater would be the sides and the top of that freezer. And they had electric heaters in there. Now, if you see that I drew that they are energized on this type of unit, those heaters are always on. But yes, Lamar, you're right that the Mullion heater on a French door refrigerator is that little metal piece that flips usually on the left-hand door. And that is a Mullion heater, and it's just in between the two doors. But remember, on a French door, you also have a freezer around there, so we do need to prevent that area from sweating. But these heaters are slowly being removed, except for on the French door, because they can't do it, and I'll explain as I get into that. But why isn't my evaporator and drain heater working in this circuit? Because that thermostat right there is bypassing. If you look, this is line 1 right here. And that means line 1 is right here on the heater, but line 1 is going all the way to the compressor. That means this is also line 1. Well, you say, well, wouldn't the current flow through it? No, because the thermostat itself has no resistance, so the current's going to bypass it until the thermostat opens. So in this circuit here, what is the cycle that this machine is in right now?
Your defrost cycle.
We're defrosting right now. Okay, and again, our Mullion and Style heater, they're always running. Even if you like turn the thermostat off in the fridge, those heaters are on, as long as it's plugged in. So, how often would this refrigerator defrost? Once a day?
I think every 12 to 18 hours.
There's no timer. So, in these two diagrams, what's energizing my heaters right now? The fact that what? This thermostat opened. And when does the thermostat open? When the refrigerator gets cold.
Is it 8 hours?
No, the thermostat is what's controlling the temperature in your refrigerator.
So this is thermostat opening and closing is what you're saying.
Well, but just forget about defrost right now.
Okay.
You got a refrigerator with a thermostat, you put it to 40 degrees. At 40 degrees, that thermostat's going to open. Now the compressor's not running, refrigerator's going to get warm, thermostat will close, compressor comes on. In this case, every time that thermostat opens, we go into defrost. And your refrigerator cycles 2 or 3 times an hour. So you're defrosting 30 times a day, 40 times a day. And then when we add that heat back into the box, the thermostat closes and we go back into cooling. This is called cycle defrost. This is when the thermostat cycles off that's when the unit goes to defrost. Now you're not going to find that often, but that's how they did it on these lower end refrigerators and older refrigerators before they came out with the timer and the circuit for a defrost. So that is what you call cycle defrost. Now let's take a look at the next diagram. All right, so the first circuit on the left is cooling or defrost. Power comes in, goes down to the timer, and the timer is closed from what two numbers? Comes in on 1, and it's going out on what? Going out on 3. That's for my timer motor. All right, but if our timer's connected here from 1 to 4, that's cooling. So our thermostat here runs our compressor, and our evaporator and condenser fans are running. And now guess what? We got our million and style heaters running. But now that we have a timer, when that timer switches like in the other diagram, now we're in defrost. Here the timer motor is always running in this diagram. And now we turn on the drain pan heater if it had one, and that's like below the evaporator, and our defrost heater's coming on. And now we turned off, not only do we turn off the compressor and the fans, but we also turned off our mullion and style heaters. So this is a defrost system with a timer, but we have two options. We have something called continuous run and cumulative run. Has anybody ever heard of that? So this is called continuous run defrost. So that means that the timer motor, if you look at the diagram, there are no switches in series with the timer motor. So that timer motor is going to defrost however many hours it is. And we'll look at the timers as we go over the circuit here. So it could be a 6-hour timer, an 8-hour timer. That means that every 8 hours, if you had an 8-hour timer, it would defrost. Let's just say 12 o'clock in the afternoon. The next time it would defrost is 8 o'clock at night. And the next time it would defrost would be at 4 in the morning. And then it would go back to, I think that's 4 in the morning, right? 8? Yeah, I think that's right. But it would cycle 3 times a day in a 24-hour period. And we defrost. That's all there is to it. It's just a basic unit, but we call it continuous run. And that's important because I'm going to bring up some other circuits. And I want you to know, and I'll explain to you how I made a mistake, not really paying attention, that I went to a customer's house, timer was bad, and I installed another timer, and I had to go back as a recall because there was something wrong. And I'll show that to you coming up. So this is continuous run every 8 hours, 6 hours, 12 hours, whatever that timer is set at, that's what it's going, when it's going to defrost. Now, real quick here, I just wanted to show you refrigerators where the mullion and the style heaters are. So on this French door, there would be a flap right here we call the mullion heater. So when the doors are closed, it will keep the air from leaking out, but also it stays warm so it don't sweat. But a mullion heater would normally be here separating the freezer compartment from the fresh food compartment. And then a style heater, just think of style as outside, would go around the outside. But now with these newer refrigerators, they've started eliminating some of these heaters. Now, this mullion strip right here, and sometimes this one in the middle, you can't bypass it. You can't remove it. But on this one, instead of having an electric heater, they put part of the condenser refrigerant line running through the box and run it right up against the cabinet where the gasket is, and use the heat from the condenser instead of an electrical heater. So this is one of the ways the manufacturers had to figure out. The government said, you got to be energy efficient. Stop, you got to make it, $3 less a year to run that refrigerator than you did last year. And so they got to figure out what can we do to make it more energy efficient. And removing an electric heater and putting part of the Freon line that's already working anyways, that's how they did it. Now on this one here, they would probably just put a refrigerant line and run it all the way through, but it would always go around. You know what? I think the freezer compartment is the other way. I think the freezer compartment's on the right. Very rare. And the freezer compartment would have either an electric heater here or a refrigerant line called a Yoder loop or a condenser loop right around here to prevent it from sweating. One of the things that I've run across, and it just so happened that I've seen it more than once on a Whirlpool refrigerator. Customer told me they touched this center wall here and they burned their hand. What do you think could cause that? It could be a dirty condenser or a bad condenser fan motor, because remember on the newer ones, instead of it being an electric heater, we're using part of the condenser and the refrigerant line from the condenser. And some refrigerators comes right off the compressor. Some come after the condenser, which are not as hot. But you go before the condenser and you don't have a fan running on that condenser to cool it down. You're going to raise your what we call head pressure and temperature. And it's going to make the center wall here very hot to the touch. It's not going to burn someone, but someone will tell you, oh, it's burning me when it's hot. What you want to do is you want to look at the condenser fan and the condenser coils to make sure that they're clean. And that's usually your biggest problem in that particular unit. Now, that's all I want to talk about those heaters. Now, I want you to see this one video real quick, because I'm going to talk about this timer.
That's hooked up to a set of contacts that switches between running the compressor motor and running the heating element in the freezer compartment. So let's flip this over. If you look at the back, you can see that this is actually the motor that turns and is connected to these two posts, which are the two posts that I have connected to power. And I'll turn this on. It's kind of hard to see there, but you can see that there's a gear spinning underneath there.
Okay, I want to go back to that real quick. So you saw the little wheel in here turning. That is the motor, okay? And then if you watch this gear, and this gear does not move continuously like the other gear. When you look inside of a timer, these gears, or the ratio of gears, determine the speed. But that's also called escapement. And part of the escapement is that the timer doesn't move like a second hand on a clock. It moves like a minute hand. Now, if you watch the red gear, and he's going to take some of these gears apart and show you, but watch the red gear, and then there's another gear underneath here, and watch how, like, even though the red gear moves, the other gear next to it doesn't always move right away. It moves like in steps in time. So they're using a gear ratio to control the time that or the speed that it runs instead of just directly the motor. I don't know how to re-get it to play. I'm sorry.
Actually, a small tooth wheel there, and then a larger one there.
You see how the red one's not moving at the same time?
Start seeing that move. And what's interesting is the tooth pattern on that is such that it only moves, like once per rotation there, the white one you can see. And then that one also has a similar tooth pattern to the one underneath here. So let's just take some of these off.
I just want to state, those wires are live. He touch any one of those terminals, he's going to shock himself. But see the red one moving? Now watch, the white one just barely moves, and then the white one don't move.
And the white one is connected to the blue one. The blue one is connected to the other blue one. And then that's connected to this white one. connected right there. Okay, and this one has sort of a tooth spline. So what that will do is turn this cam. So there I just moved it. It actually was in defrost. So this is regular running. So that inner set of contacts is the compressor running, which would be the inner two contacts there. And then after a certain amount of runtime, now this is only running when the compressor is active, so it's not running all the time 24/7. It's only running when there's power to the.
Now, when he says it's only running when the compressor active, he's talking about the cumulative run circuit and not the continuous run, by the way.
Compressor, so it measures how much compressor runtime there is. And then when it gets to the end there, okay, you can see the inner set of contacts is connected. That's the compressor. And then it switches to the left set of contacts.
Okay, I want to explain something here. We're going to break down the timer a little bit, just what's going on inside the timer here. And if I can't mouse over it, I was trying to mouse over it. I got another picture I'll have to show you.
Coming off of that one, and that will go to the defrost element for a very short period of time before it clicks back to regular operation. Okay, so that is how.
Okay, you're not going to be able to see my mouse. I don't know why this program is built like this, but if you look at the 3 terminals on the left and the one by itself on the right, the one by itself on the right is usually neutral for the timer motor. And this little red thing that's got these numbers on it and letters on it, that's a little capacitor in there to control the electrical flow. So the power comes in, goes to the right there and goes through the capacitor, and it goes down to another terminal. But if you see that other terminal there, which is close to the blue gears, do you see 2 openings there? The one that the capacitor goes down, but if you look a little bit closer, there's another like opening there with like a pin inside. That's your timer motor. There's a metal stub coming in touching that. Now if you look where the other wire is in the middle of the 3, there's another pin right there just above where the wire's connected. Those are the 2 points where the timer motor's connected in the timer. We'll take a look at that in another drawing, but that's also important because I'm going to get back to that story that I had about a different timer.
The defrost timer works.
So I didn't play the whole video. I'm not going to bore you guys watching the video. So let's take a look at these timers. There's a few differences in some of these timers. So, guys, take a minute and look at these timers closely and see if you can identify some of the differences. Anybody find anything different from them? Not one difference?
Yeah, I was going to say that the only difference I see is they numbered differently.
Yeah, the pins are numbered differently too. Look at their.
I can also say the time. Yeah.
Yeah.
The time difference on them.
Yeah, that the cooling cycle, the 6 hour and 21 minute, most of them are an average of 21 minutes. So the 6 hour means it's going to stay in the cooling cycle for 6 hours, and then when it goes into defrost, it's going to defrost for 21 minutes, and then it go back into cooling. All right. Now the 2143 is the normal number pattern for these timers, but you see that there's 2 of them that's 4321 and 4132. Now, even though the numbers are different, most of these timers have the switch here, like we saw in the video, and another switch here, and then this is neutral for our motor. And I'm just going to draw a circle here like a motor. So one side of the motor is going to pin 3, and normally the other side of the motor goes to pin 1. So power comes in here, goes through the timer motor and out. I think they had a capacitor there too, and it goes out here. And that's where he connected his 2 power wires. So the other 2 pins, which is 2 and 4, is your cooling and your defrost. Okay, so power will come in here, and if it goes one way, it goes cooling. It goes the other way, it goes defrost. There is another one that is totally different, which is this one here. Now, if you're going to carry a timer on your truck as truck stock, the one in the upper right-hand side, I recommend because it's universal for almost all refrigerators. Now, I haven't brought up the other circuits yet. I'm going to show them to you in a minute. But having this extra wire, does anybody know? Look at that one with the wire hanging off, and look at the diagram below. What is different in the diagram that's drawn on the 2 timers? Look at the motor. Do you see anything on the motor? I'm going to move this timer out of the way. I'm going to make these bigger. So if you guys are having an issue trying to see those diagrams. Can you tell the difference between these 2 in the wiring diagram? Look at the timer motor. This motor's connected to pin 1 and 3. Okay, but this motor is connected to 3, but what's the other side of the motor connected to? Nothing, it's this wire here. And what that is, it's hard to show you in the picture, but it's got a groove here that will slide over this pin and still allow you to put that quick disconnect that comes with a defrost timer and reconnect it. So you could put this wire of the timer motor on any pin location you want, but you need to know, well, what pin location do I put it on? And I'm going to bring up this story, and then I'm going to show you the diagram. Is I went to a customer's house on a Whirlpool refrigerator, and the defrost timer was bad. How did I know it was bad? I advanced the defrost timer into defrost. And let me just clear this here, because if you look at this line right here, and you look at that dot right there on that dial, wait a minute, is it that one or the other one? Let me see something here. I don't know if it's this one or this one. It's one of these. But you line that up with this line here, and you're in the defrost cycle. Most timers have those notches there for you to line them up. But when I went to the customer's house, I was like, okay, it's not defrosting. So I advanced the timer into defrost, and I hear the heater coming on. I hear the ice dripping and melting, and everything's working. So that tells me what is good. Does anybody know? If I hear the heater and I hear the ice melting, that means what?
The heating element is good?
Well, it means the heating element is good. What about the defrost thermostat?
Yep, it's good because that continuity all the way through it.
Okay, so if the heater came on, and even the timer switch to the heater is good, but you definitely know it's a defrost problem. It's not a seal system problem. So the only option could be is maybe the gears in the timer are messed up, or the timer motor's bad and it's not advancing into defrost. And that's what happened to me on this customer's refrigerator. I went there, saw it wasn't defrosting. I advanced it into defrost. I hear the heater. I hear it going tss, 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 as the ice is dripping off the evaporator and hitting the heating element. I'm like, okay, let me go up my truck, get a timer. Go to the customer's fridge, open it up, take timer out, slap the new timer in, one plug, all the wires line up, put it back in the fridge. Okay, ma'am, have a good day. Week later, a week and a half later, a customer calls me back. It's not cooling again. It's not defrosting. I put the timer in defrost. Heater comes on. I'm like, what the heck? And I looked at the diagram and realized that number 3 is usually neutral on the timer motor here, on either one of these. But where the timer motor gets its power from, in the diagram on the left, it's getting it from the center pin here, pin 1. So 1 and 3 on almost all refrigerators is power neutral. You should have 120 there almost all the time, except for, I'll show you some examples. But anyways, that is where power comes into the timer. But in this case here, sometimes the power of the motor doesn't go to pin 1. I nicknamed this timer a defrost timer with a flying lead. I don't know, I came up with that in the 80s, so don't knock me for it, but this is a universal timer that can be used on any one. If I was replacing the timer on the left for the timer on the right, I would just take this wire and slide it on pin 1 right here, plug it in, and I'm done. I would do it the same way the original timer was wired. Now, the only difference is it's 8 hour instead of 6 hour. Does that make much of a difference? Not really, but the longer you go between defrosts, the less efficient your refrigerator gets till it melts the ice off the tubing. So if you're in areas that are very high humid areas, you're in Hawaii, you're in South Texas, you're by the ocean, you're in Florida, Alabama, any one of these, you'd rather have a 6 hour timer instead of an 8 or 12 hour timer, or they even have 10 hour timers, because with that high humidity you want to defrost more. But if I lived in Arizona or Nevada or some of these other states that have very little humidity, heck, I put a 12 hour timer in there, let it defrost once or twice a day. That's all I need. So that's what this timer is. But the nice thing about this timer, and I have the part number in the top, that it's universal. So if you had to carry one on your truck, and by the way, this ER number is also this timer number, ER 482493. It can be used on almost all refrigerators, where if you put this one on a customer's refrigerator, because pin number 1 is feeding power into the motor, on this next circuit, it's not wired that way. And the timer won't advance in certain parts of the cycle. And that's what happened to me. So let's just take a look and see the wires that are coming in compared to the diagram. Pin number 2 here is what? According to this diagram, what is pin number 2?
The defrost heater?
That's a defrost heater. It's the pink wire, and it's defrost. Okay? Now, what you will find is no matter what type of refrigerator you have, as far as like continuous run or cumulative run, and we'll get to that in a minute, that these 3 pins here are usually the same. So this one here is almost always defrost. Okay? Pin number 1 is what? It's black. And it's line 1 coming in. And that's this one right here coming in. Alright? Pin number 4 is orange. And we're going to the cooling components. And pin number 3 is white, which is neutral. And this is cooling. Alright? So that's this timer. Simple timer. Let's look at this one. There's no numbers in this diagram. As a matter of fact, one of my students was doing an assignment and said, hey, I'm looking at this diagram. I see colors, but I don't see the numbers. So which number goes to which color? Well, since you guys are all so involved here, I'll do it for you. Black is power coming in, but it's also the common position of the switch, which is pin 1. So it is black. Okay? So power comes into the switch and either goes to orange or goes to pink, which is really like the same thing we had here, right? Didn't the power come in black and go to orange or pink? So power came in and it goes out to orange, and I think the center number 4 was orange, and number 2 was pink. But we got a problem here because on the other diagram, pin number 3 was white, but now it's red. Does that look accurate? Take a look at it closely. It seems accurate, right? Well, we got a problem now, because if we look at the diagram on this timer here, this diagram right here, I'm going to copy this time. I'm going to tell you what, I'm going to bring that timer over and put it alongside, and let's see something. So if we looked at the diagram here, number 3 is going to the motor, and number 3 is going to the motor. That's correct, right? Number 3 goes to the motor, and that's this red wire going to the motor. We're good. And black comes into the switch, so black comes into here. We're good. But we got a problem now, because where is my timer motor connected?
Is it on the orange on 2?
Well, there's a capacitor, but there's a switch here, so the timer motor is not touching orange, is it? And then really, if you look at it, power comes in here, goes through the thermostat when it's cold for the compressor to run, and I'm just doing it real fast, and the evaporator fan to run. But that brings line 1 to red, and black is line 1. So when this switches over here, I have line 1 here. Wait a minute. Now I don't have line 1 here. So what's going on here? The timer motor is connected to what? To where the pink goes, which would be number 2. But they have it on number 1. So now the timer motor has to be connected here. And that's where the flying lead comes in. Because inside these regular subcode timers or whatever, manufactured timers, this is how the timer motor is wired between pin 1 and 3. But on the Whirlpools, it's pin 2. Now, here's the installation instructions. And they tell you, you know, oh, this is how you're going to do it. And remove the plastic tab. We're going to connect this on a normal timer. We're going to connect it to pin 1. And if we go over here, if you're dealing with a one with a red wire like the one we just talked about, where are they putting the timer lead? They're putting it on terminal 2. So if we go back to this one here, we're putting that extra lead on 2 where the pink wire is. Do you guys see that? If you put this timer on this refrigerator in this diagram, this is a Whirlpool top mount side by side, older mechanical one, has no control board. If you put this timer in place of that timer, it will not advance in cooling. It'll advance in defrost, but it won't advance in cooling. So how does this circuit work? Well, right now, let's say we're in the cooling cycle. Power comes in, goes through the timer, through the thermostat to the compressor, but the power also goes to the timer motor, and it's in series with our defrost heater during cooling. So if the bimetal's open, our timer won't defrost. Okay? But what happens when we go into defrost? So now I'll use a different color, but power comes in. Our timer is going to switch from black to orange to black to pink and send power to defrost. But our timer needs to get power because if we go into defrost, we'll never bring the refrigerator back out of defrost. So we have to go through here, and we use the compressor because the windings are only like 2 or 3 ohms of resistance during defrost for the neutral of timer. So look at how the power reverses on this timer. It was going the other way in cooling, but now it's going this way in defrost. And that's why you have to use that flying lead. Now, why did they create this circuit? Anybody know why? Well, y'all on the ball today. We're doing it because we're cycling the timer on and off. When we're in cooling right now, power's going to come in through here, go through this timer switch, not to the motor, but if you look, this diagram, the thermostat's open, so our compressors are not running, our fan's not running, but also our timer is not advancing when the thermostat's off. The timer will only advance when the compressor's running or defrost. What's the advantage of that? Anybody know? I'm going to start sending out stuff for you guys to read and stuff before I start these classes. This is a cumulative run timer. And what that means is that your timer could be an 8-hour timer, 6-hour timer, 10-hour timer, whatever timer it is, it's in this unit. But whenever the thermostat opens, the timer stops counting. So let's say the thermostat's closed for 20 minutes, you know, so the timer only advanced 20 minutes, but the thermostat opened back up because the refrigerator's cold, timer's not moving. So we still got another 5 hours and 40 minutes to go, and then the thermostat closes and the timer moves another 30 minutes, for example. So we're delaying how long our timer goes into defrost. Most refrigerators don't need to defrost every 6 hours or every 8 hours. We can change the way they defrost based on the customer's usage. For example, if I live by myself, how many times a day am I going to go in the refrigerator? 5, 6 times a day, especially if I'm working. But if I have a family of 5, how many times is my refrigerator door going to open? All day, every day. So the more you use it, the more the thermostat will be closed, the quicker it'll reach that 6 hours of accumulated run time. So it's still a 6-hour timer, just like everything else, but the thermostat's controlling how much time the timer gets power so it don't advance that fast. The more you use it, the faster we're going to defrost. The less it gets used, the less we're going to defrost. And that started what we call cumulative run. Some other manufacturers have done it too, and I have a few more diagrams to show you. But the point is that concept of cumulative run, remember that in part 2 of this class where I start talking about the electronic controlled defrost systems, that they started using the logic of, well, if you use it more, we're going to defrost more often. If you use it less, we're going to defrost less often. And the less we defrost, the more energy we're going to save. So we got rid of the million heaters, and now we're going to change how often we're going to defrost, because that's another way we're going to save energy. And that's one of the reasons why they went from continuous run to cumulative run. And it's not any different except for the way this timer is wired. Now I want to go back to where that video was. Remember I told you that the timer motor was connected on pin 3 and 1, and I was trying to point out to you Let me see if I could get it. Hold on one second.
Take a look inside of there. It's basically just a gear reduction.
I'm going to pause it and then screenshot it so I can draw on it. Because I want to show you something that I did to make that timer work, but it wasn't the one with the flying lead. I made the customer's refrigerator work with that same timer. So let me just paste this into a new page here. Insert page after this one, and let's just paste this diagram in here. Okay, so now I can edit it. So what I was saying earlier was that right there and right there, there's pins. If you take the timer motor out, the timer motor doesn't have any wires. It has two long metal pins coming out of it. And when you connect the timer to this box, they slide through these holes, and this is where power's coming in. And then this goes through the capacitor and neutral comes out. And that's a regular timer, pins 1 and 3. But I had a customer who had a refrigerator that had that flying lead type of system. And I needed the timer motor to connect here. So on the one I had, I saw a piece of metal coming up and over, and it went down in there, and I realized, hey, that's the timer motor. So I moved it to this pin, and the timer motor was still connected by this pin, and now all of a sudden it's wired like the other timer. I didn't need to buy another timer. The one I put in that lady's house that didn't work, I opened the timer up and I moved to position where the timer motor connects inside instead of that wire that's on the outside that I showed you earlier. Anybody not understand what I was saying that happened here? Okay. So let's go a little bit farther. Here are the two timers, and I just showed you in the last screen, but here is how I moved that timer to the other position. It was on pin 1, but I needed it on pin 2, so I moved this wire into this pin location, and by moving the wire to this pin location, now I made it work like the whirlpool diagram that we see down here. So some of these timers you can do this to, and in the last one I showed you really couldn't move it, but the one that has this pin on the inside, I could move it to 4 or 2 or 1 or whichever one I want and make that timer work like that. So that's how that timer works. So this is the one with the flying lead, and this can be used for any refrigerator that you want to use it for. Now let's talk about the defrost thermostat. The defrost thermostat, we have 3 different defrost thermostats here. This one says L62. This one here says, well, I could barely see it. I think that's an L45, and this is an L47. That means the limit at which the contacts inside the thermostat open. So we have different ones here, but we said about a 47 or 45 is average for what they are. But inside the thermostat, at the very bottom here, right where these clips are, there's a metal disc which is represented by this blue line here. And when you go into defrost, the heat causes this disc to warp, and it opens up this contact here and turns the defrost heater off. So even though it's a 6-hour, 21-minute defrost cycle, the defrost thermostat will open and turn the heater off before the 21 minutes once we get whatever temperature that the thermostat is set at here. So L means the limit. So on dryers and other machines that have these thermostats, that's the temperature of the thermostat. Could you use a different one? Yes, but if I used a 62-degree one in one that's supposed to be running in the 40s, I risk adding more heat into the refrigerator, and now it's going to be less energy efficient because it's got to run longer to get that heat out. So the defrost thermostat is almost always located on the suction line. This is the one where the freon is running back to the compressor, and then the capillary tube is on the other side. Now this one here, you can see frost build up. That's either one of two things. One, they ran it without the cover on it, so the fan wasn't drawing enough heat, or we have a sealed system problem and it's not filling up the evaporator with proper freon. But this here opens at 47 degrees, but because it's attached to this line and this line is running at negative 15 degrees, this thermostat will close real quick. It doesn't mean the whole air behind here has to be 47 degrees, because once this tube gets cold enough, this thermostat will close and be ready for another defrost circuit. So if we look here, the defrost bimetal does different things in different circuits. In this case here, when we're in defrost, that defrost bimetal controls the heater. And let's say it's a 6-hour, 21-minute defrost. Then this bimetal here will take 21 minutes to open, or will it take the timer 21 minutes to open? What do you think?
Would it take the defrost 21 minutes?
Well, you talk about the timer or the bimetal?
The bimetal.
No, the timer will stay in this cycle from 1 to 2 for 21 minutes, and then the timer will go 1 to 4 back into cooling. So that's what the 21 minutes. The 47 degrees or whatever this thermostat's located is temperature. And depending on how cold the box is and how long it takes to melt all the ice will be how long it takes for that open. That usually opens between 10 and 12 minutes. We leave it in defrost a little bit longer for two reasons. One, let's say it takes a little bit longer to melt the ice, so the timer's got that much time in a circuit. But the other reason is that the defrost bimetal opens, but now you've melted all this ice off your tubing, you've created a lot of steam or moisture back there. And some manufacturers made some changes, and I'll show you that they let it sit for a little while before it goes into cooling without the heater on, so that any moisture or humidity that was created during defrost doesn't get blown into the box and go over all your meat packages and create like a frost pattern, so you can't tell, is this chicken, steak, pork chop, what is it? I can't see, it's got ice all over it. So that extra time for defrost is to cool down the humidity to prevent it from blowing over your packages inside your freezer. Now with this one here, I said it earlier, is that if we go into defrost, then the heater comes on, but this heater is waiting for this bimetal to shut it off or the timer to shut off. Usually a bimetal comes first. But watch when we go into cooling, we send power to compressor, but this timer motor, if we went into defrost and now we came out of defrost and now we're cooling, but the bimetal's open, our timer motor is not going to advance. Our timer motor is going to stay and wait for this to close to advance. Now one thing neat about this one is that we have two test terminals. So inside the refrigerator compartment there's going to be a plug with some pink and brown wires, and they're not connected to anything. You can use that plug to check the bimetal. You can use that plug to ohm out the heater. You go from here to neutral, and there's a light bulb inside the refrigerator gives you your neutral, and you could check your defrost heater for continuity, your bimetal for continuity, and then you could check your timer motor from pink to black. So, I'm sorry, not timer mode, but your timer switch from pink to black. So we have this, the bimetal, and the heater, but this one plug allows us to do that. Let's say I went to a customer's house and it's not defrosting, and I check pink and black and it says this is open, but I see it's not defrosting. I could run a jumper wire on that plug put the timer in defrost, and get the heater to come on and melt that ice back there. Now that'll be so I can open it up for service or the customer get temporary cooling till I can replace the bimetal. Never leave this wire here, because when it goes into defrost, if it stayed in defrost for 21 minutes, that heater will be on for 21 minutes. But if the timer goes into defrost and gets stuck in defrost, that heater will make that refrigerator like an oven, and it'll melt everything in your fridge and it'll cook all your food. So don't leave it bypassed. That bypass is only for testing purposes. Okay? Now, if we look at this diagram in a Mana refrigerator, look at this. We go into cooling, and I'm going to use my marker now. We're going to go into cooling. Power comes in, goes through our thermostat, goes through our timer, and feeds our compressor and our condenser fan. But look, our freezer runs through the defrost thermostat. So when we go into defrost, our circuit for defrost, and I'll use the black, we go to defrost, our defrost is doing this. And the fan don't run. But once we're in defrost and that thermostat opens and we go back to cooling, this fan needs this thermostat to close before it comes on, even though the compressor and condenser fan are running. That is another way they prevent the fan from coming on and blowing all that moisture over top of the stuff inside your freezer. So that is something you need to be aware of. It's very similar to that freezer I started off at the beginning telling you the story. Is I went to someone's house, the fan wasn't running in the freezer. I go to the truck, get the freezer fan, and I come back and the fan's running, and I realized that the fan was waiting for this thermostat to close. I just must have happened to get there before it just came out of defrost, and that's why the fan wasn't working. So the cooling problem was something totally different, and I found it. But don't think the freezer fan is bad until you determine, hey, is it this type of circuit? Is it this type of circuit where it'll keep this timer from advancing or keep this fan from running if the thermostat's not closed? So this is a way that they change the way in which these components are wired. And if you're not familiar with the product, you might misdiagnose it just by saying, oh, the freezer fan's not working. I see the compressor and condenser fans running. I'm just going to go order a fan because, you know, if it was a cold control is bad, the compressor wouldn't run. If the timer wasn't bad, the compressor wouldn't run. So it's got to be a bad fan motor. And you could be right. But if the defrost thermostat is bad, your freezer fan won't run. So that's something you need to know. On the Manas, they do that. Now look at this one. Here's our timer motor running here. But look at our defrost heater. If I wanted to check my defrost heater and defrost thermostat, I'd check pin 2 and pin 3. And that'll test this circuit here for me. Now, if the heater's bad, I won't get any reading at all. I'll get something we call infinity. That means open circuit. But if the defrost thermostat is bad, you see, for diagnostic continuity, check for 240,000 ohms. So there's a resistor down here. So if this is open at the switch, which is on top, and we ohm out these same two terminals and the heater's good, I'm going to get 240,000 ohms telling me my bimetal's open. So I can make that test from my timer and to see if the bimetal's good or bad. So this is the last screen. I just wanted to talk about defrost heaters. This heater here is commonly found on the GEs. Some Maytag and Admiral use glass tube heaters as well. This one here is for a side-by-side refrigerator where the freezer actually has two sets of coils. and there's one heater here and one heater here in the bottom, and that's why you see these two heaters. In some of them, they only have a single heater, and this has like a splash guard to prevent the water from getting inside the heater. But if you look at this as a metal heater, very, very similar to the ones you have in your ovens or your stoves. Does anybody know what this heater is?
Is that the one for the ice maker?
Very good. Do you remember which brand?
I think it was the Kenmore, I think.
Okay, but that was the Frigidaire one. That was the one we keep the water in? That you're talking about?
No, the other one.
Well, there's two of them right next to each other. So that is a Frigidaire refrigerator, but the ice compartment in the refrigerator has, hold on one second, I think I have an image I want to bring up. Hold on just one second. Of course, yeah, I'm not going to find it while I trying to tell you. But the defrost heater inside the Frigidaires, you might mistake it for the actual evaporator. And this one also has a defrost thermostat on the evaporator. I had an image somewhere, but I apologize. I'm not able to find it right this second.
I found my image if you want to see it.
I don't know how to make it so you could see it. You could share it. Let me see.
Can you see mine?
Hold on a second. I'm not in the meat. Where you got it? Yeah, that's it right there. And right there in the upper corner is the defrost thermostat right there. And then the heater is running. It looks like the evaporator. It's the same color, but it does pull out. Yeah. And that's what it looks like.
Yeah.
So those are the components of a defrost. So in the next class I give, I'm going to go over the electronic controls and sensors. Like if you look down here, this one at the bottom right, this has a thermistor here, which could be used to sense the temperature of the evaporator for defrost as well. Now some of those that have a thermistor still have these, but those are only used for safety. If for some reason a thermistor don't work and the board don't turn the heater off, then this bimetal here is supposed to be wired in series with the heater and stop it from overheating if the control board fails. So that's it for the main components of the defrost circuit. I'll put this up online. Yes. Yeah, go ahead.
I got a question. So one time I took out a defrost heater, right? I mean, defrost bimetal, I'm sorry. And I couldn't test it. So I cut it and I put in ice and I checked ohms.
Well, it might, it'll work if we go, let's go back to that defrost thermostats. That's a good question. A 47 degree thermostat or a 62 degree thermostat, they will close at 62 or colder, or 47 or colder. So if you put it on ice, you could do that. They sell a can. Let me see something here.
The spray can?
Yeah. Let me see if I can find it now. So they have these small cans. If you look here in the top left, it says quick freeze. And you could get a can like that and you could shoot a little bit of this on the bimetal and it will freeze it real quick, so you don't have to disconnect it, stick it in ice or whatever. You could just quick freeze shot it and see if you can get it to close. And if it don't close, then we know the bimetal's bad. So if you got a refrigerator just came out of defrost or a refrigerator that the bimetal was bad, you'll never read it. But if you shoot it with this freeze real quick and you see ice form on it, it should close and you should get a reading at that point.
Yeah, I gotta try that. I didn't have that on my hands, so I just used ice.
Well, I just want you to know that you could get these little freeze fast things that you can use that would do it. Now these freeze fast here are like for injuries, but Doesn't
Yeah.
matter. It's safe if it gets on your skin, so it should be safe if it gets on the bimetal or something like that.
I'm pretty sure you can also use the one that knocks out the dust on the computer keyboard.
Used to.
I'm pretty sure you can use that too.
I think they've changed some of the chemicals inside them because they used refrigerant, what they call CFCs, like R12, R11. They use the CFCs inside of those cans. Even paint cans use CFC, use refrigerant to pressurize the can. But now because of the EPA, they could no longer use CFCs. So the cans back in the day might have done it, but the new ones may not. Just so you know.
I was reading about the EPA that's saying that the CFCs are the most dangerous to the environment. So I'm guessing that's why they changed them.
Yes, that's why they stopped putting them inside of spray cans. All right, so that's it for today. Guys, got any other questions before I go?
Yeah, so I didn't see the last video, but in the last video you're talking about the electric components, right? And you're saying, oh, you're gonna test DC positive, and you said in the video you shown that you put the multimeter lead on the positive was red and the negative or the common was black. Is it possible to put it upside down, or do you have to put
if you have
red with positive and black with the common?
If you have a digital meter and you reverse what they call the polarity, the meter will just say negative 12 volts instead of 12 volts. So you can test a DC volt and not worry about which way you put your leads. The only thing is, instead of it saying 12 volts, it'll say minus 12 volts, negative. And just by reversing your leads, it'll just say 12 volts. So it won't hurt your digital meter, especially that low a voltage. So that's
I'm not worried
thing.
about the meter. I'm worried about the unit.
No, it won't affect the unit in any way. So you'll be okay with checking that voltage. Now that video is online. It's in the members section. I'm going to go ahead and post this one in the public section and the members section. But I'm going to continue. Like I said, I'm going to keep building these videos until I have a full refrigerator thing, of progress.